Okay, now let us take a look at this question. This is also from JEE Advanced 2025. So we have been given three differential equations, this one, this one, this one, and we need to find this limit. So the typical thought process is, I'll be following different thought process. The typical thought process is that you find the value of y1 of x, y2 of x, y3 of x, then you get an expression with some integration constant, use these values in order to get the actual functions, right? But I'm going to do something different. So what I've been taught is, whenever I see like several functions getting multiplied like this, a thought crosses my mind. Let me share that concept first, then we'll proceed on to the solution. So if we have some function gx is equal to f1x, f2x, f3x and whole up to fnx, then there is a really good formula which relates the derivative of gx and gx as summation I is equal to 1 to n fi dash x by fix. No need to be scared of the summation. I'll write it like in an expanded form, f1 dash x by fx f1x plus f2 dash x by f2x and whole up to fn dash x by fnx, right? So this thought crosses my mind whenever I see like several functions getting multiplied. So now let us proceed on to the problem. Let me minimize this thing and then we'll proceed on to the problem because we need space here, right? What to do with this one? Let's delete this one. If you want to make notes of it, go back and make it. Okay, fine. Now what we are going to do is, as in the expression we saw that g dash x by gx is equal to f1 dash x by f1x plus y1 dash x by plus f2 dash x by f2x. So here can you notice that this thing is y1 dash x by y1x, like we are getting the terms of the form f1 dash x by fx f1x from these expressions only. So the expressions are supporting a line of thought. So let us do it. First of all, what we are going to do is use the L'Hopital's rule. So in the L'Hopital's rule, what we need is the derivative of this function. Let us call this gx. We need the derivative of gx, that is g dash x. So I need to shift this gx over there. I need to shift the gx over there along with the summation. So what is gx? y1x, y2x, y3x times summation f1 dash x by f1x. That is, first term will be sine square x, second term will be cos square x, and third term will be, I am writing it in a simplified manner, 2 by x cube minus 1. Alright. So as you can notice, sine square x plus cos square x is equal to 1, and here it is minus 1, so these two will get cancelled. There will be more terms after the differentiation, which will be this by e power 3x, 3 power 3x sin x plus e power 3x cos x. This will be the value of the denominator. Why did I use a L'Hopital's rule? Because you could see that it is a 0 by 0 form. Okay, now let us proceed on to the next step. So let us write what we got over here in a simplified form, like in a clean manner. We get, let us take 2 out. You understand the step, right? It is just a calculation step, nothing much. The real thought process begins after this, like the real calculation part, not the thought process. X cube plus 1 by, look at the denominator, and is the denominator bothering us? Is the denominator bothering us? No, it is not bothering us because it is not tending to 0. Our denominator, as you can see, is tending to 1. So I'm just writing over here something that tends to 1. I haven't replaced the values yet. I'm just writing this bracket as something that tends to 1. This value itself, but in a short form. Okay. So what is the value bothering us now? Here, this value, this whole thing is bothering us, right? This expression, let me show you. This expression is bothering us. So now what we need to do is actually integrate and solve the differential equations, but I am going to bypass the putting of constant step. Please look carefully. I'm going to bypass the putting of constant step. Just look at it carefully. So once I integrate it, I'm doing it mentally. Okay, dy1 y1 comes over here, so I'll get ln y1 is equal to sine square x. Sine square x, I can write it as 1 minus cos 2x by 2, right? So this will be half x minus sine 2x by 2 plus some constant c1. Let's call it c1. I'm not going to calculate c1. I'm not going to do it. You just see what happens. Ln y2 similarly is equal to cos square x would be 1 plus cos 2x by 2, right? So it will be half x plus sine 2x by 2 plus c2. And similarly the third one, I'm going to write it over here. Ln y3. Ln y3 would be equal to, I'm going to integrate this, right? So the simplified expression came out to be x 2 by x cube minus 1, something like that, right? So it'll be minus of 1 by, I am integrating mentally, okay? It is really easy. Minus 1 by x square, okay? Minus x plus some c3, okay? So y1 will be e power this thing, y2 will be e power this thing, y3 will be e power this thing, all right? And when these three get multiplied, I will be having, for now I'm just manipulating this expression, okay? I'm not bothering on these two, all right? I'm not bothering on these two. So what I'm going to write here is this expression only, okay? Once we get it manipulated, I'll substitute it into the real expression, okay? Limit extending 0 plus, I will have e power. Let's look at those expressions. X by 2 minus sine 2x by 4. I will write the constants at the end, okay? At the end. Denominator is of course x cube, and whatever I'm writing here is of the power on the power e, all right? Plus x by 2 plus sine 2x by 4 plus, okay, not plus, it will be minus 1 by x square minus x plus c1 plus c2 plus c3. Now look carefully at page. Okay, so what happens now is limit extending 0 plus, it will be e power. So look at this expression, these two will get cancelled out, right? And x by 2 plus x by 2 will form x, which will cancel out this x. So at the end I'll have 1 minus 1 by x square plus c1 plus c2 plus c3. Okay, whole divided by x cube. Now I have to find a finite limit, right? This is some term which is tending 0, and if c1 plus c2 plus c3 is not 0, this value will be some finite value, as e power minus 1 by x square x tending 0 would be equal to 0, right? It would be tending 0, right? But if c1 plus c2 plus c3 is not 0, I will be having some finite value in the numerator and my limit won't be defined. Is that acceptable? I have to find the value of the limit, but it won't be defined if c1 plus c2 plus c3 is not 0. So c1 plus c2 plus c3 has to be 0. c1 plus c2 plus c3 has to be 0. Got that? So my limit simplifies to, okay, let me write it over here. c1 plus c2 plus c3 has to be equal to 0. My limit simplifies to limit extending 0 plus e power minus 1 by x square by x cube. Now another amazing observation, all right. So what is the derivative of e power minus 1 by x square? What is the derivative of e power minus 1 by x square? It is e power minus 1 by x square into 2 by x cube, all right. So just multiply 2 over here, divide 2 over here, and what we get is limit x tending 0 plus half d by dx of e power minus 1 by x square. Now think graphically. What is the value? What is the graph of e power x? It is something like this, right? Yes. So what is the slope when, look at this value, minus 1 by x square tends to minus infinity, right? So what is the value of slope when x tends minus infinity? It tends to, the slope tends to 0, right? So that term has to be equal to 0. This term has to be equal to 0. Half into 0 is 0. Let us come back onto our expression. This term tends 0, all right. This term is 1, this term tends 1, and the value will be 2 times 0 plus 1 by 1. Answer is 2. Alrighty. So here the answer is 2. This was a pretty good question. Let's move on to the next question.